Welcome to True Projects. In this video, we are going to see criminal identification using machine learning and face recognition techniques. Introduction. The process of identifying criminals has changed over time as criminals have gotten more adept at concealing evidence. Important biometric methods that automatically identify and verify identity using facial features include face recognition and detection. In order to classify facial features and match them with databases, this technique extracts significant facial characteristics like nose length, eye distance, and eye color. In addition to training and evaluation techniques, the process involves detection and identification. Objective of the project. The goal of this project is to use cutting-edge face recognition and machine learning methods to identify criminals. In addition to examining the efficacy of additional methodologies like HOG-SVM and HOG-KNN, it includes the use of pre-trained models like MTCNN and FaceNet. The project's goal is to combine these various methodologies to produce a thorough and precise criminal identification system that makes use of the advantages of various feature extraction and classification techniques. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python, ideally of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload criminals dataset. In this module, the project begins by uploading the dataset containing images of individuals, both criminals and non-criminals. This dataset acts as the foundation for training and testing the algorithms. Each image corresponds to a specific person. The second module is preprocessed dataset. This module involves the initial preparation of the uploaded dataset. Each image is processed to detect faces using the MTCNN, that is Multitask Cascaded Convolutional Networks pre-trained model. Once the faces are detected, the FaceNet model is applied to extract distinctive features embeddings from these faces. These embeddings represent the unique characteristics of each individual's face. The dataset is then split into training and testing subsets to facilitate the subsequent training and evaluation of the algorithms. The third module is train SVM using MTCNN and FaceNet features. In this module, the support vector machine algorithm is trained using the embeddings obtained from the FaceNet model. SVM, a machine learning technique for classification, aims to identify a boundary or hyperplane that best separates data points belonging to different classes, in this case criminals and non-criminals. The SVM learns from the training subset, capturing intricate patterns within the facial feature embeddings that distinguish between these two groups. The trained SVM is subsequently evaluated on the testing subset, quantifying its ability to accurately classify individuals based on their facial characteristics and yielding crucial insights into its performance. The next module is train HOG-SVM. The histogram of oriented gradients (HOG) is a feature extraction technique used for object detection in images. In this project, the HOG-SVM module involves applying the HOG feature extraction method to the images in the dataset. The extracted HOG features are then used to train another SVM classifier specifically for comparison. This module explores the performance of HOG-based SVM in criminal identification. The next module is train HOG-KNN. Similar to the HOG-SVM module, the HOG-KNN module applies the HOG feature extraction to the dataset images. However, in this case, a K nearest neighbors KNN classifier is trained using the extracted HOG features. KNN is a simple classification algorithm that assigns a label to a data point based on the majority class of its K nearest neighbors. This module assesses the effectiveness of HOG-based KNN in criminal identification. The last module is criminal identification. In this module, the developed algorithms are put to the test on unseen test images. A user uploads an image and the trained SVM classifier predicts whether the individual in the image is a criminal or not based on the extracted features. The matching percentage indicates the degree of similarity between the individual in the uploaded image and the criminal profiles in the dataset. Execution. To execute this project, first we need to open the code folder which contains the project source code files. So this is the dataset folder in which I have 6 different criminals folders. So I'm opening the Osama folder. These are the Osama images I have. Similarly, we have respected criminals images in other folders also. We will use these images to train the models. This is the model folder in which I have .hy and numpy files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is the test images folder in which I have these test images on which we will make the predictions. These are Python main code files, and this is dataset link text document in which I have a link to download the required dataset, and this is run.bat file. Instead of executing the program through command line interface, we have created Windows bat file to execute the project. Now double click on run.bat file. This graphical user interface will be opened. With this, we're interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Criminals Dataset button. A dialog box opens, select the dataset and click on Select Folder. So in the text area, we can see a confirmation that dataset is loaded, and these are 6 different criminal lists found in dataset, and this is the confirmation that MTCNN and FaceNet models are loaded. Now click on Preprocess Dataset button. So after pre-processing, total images found in dataset are 59, and this total dataset is split into train and test sets in the ratio of 80:20. Now train set includes 47 records and test set includes 12 records. Train set is for training the models and test set is for evaluating the performance of the models. Now click on Train SVM using MTCNN and FaceNet features button. So this is the SVM confusion matrix graph. So in this graph, on x-axis I have the predicted class and on y-axis I have true class. These diagonal boxes, the green and yellow color boxes, are the true classifications, the correct classifications, and the remaining boxes are the misclassifications. And we can see there are very few misclassifications. Close this graph, and in the text area we can see the performance metrics, accuracy, precision, recall, and F-score of SVM algorithm. Now click on Train HOJ SVM algorithm button. So in this confusion matrix graph, we can see there are many misclassifications. Close this, and here we can see the performance metrics of HOJ SVM algorithm. Now click on Train HOJ KNN algorithm button. And we can see there are many misclassifications in SVM KNN model also. So this is the performance metrics of HOJ KNN algorithm. Now click on Criminal Identification button. A dialog box opens. These are the test images I have. Select any of these images. I'm selecting the first one and click on Open. So this is the matching image, and this is the uploaded image on which the model has predicted the criminal and drawn a bounding box. And we can see the predicted name. It has predicted him as Osama, and we can see the similarity score beside the name. Close this images. Again click on Criminal Identification button. This time we'll select another image. I'm selecting the 11th image and click on Open. So this is the matching image. Close this image, and here we can see no match found. So he is not a criminal. So similarly, we can upload other images and detect from them. And the conclusion here is, this project provides a strong framework for criminals identification by utilizing face recognition and machine learning, including the use of pre-trained models like MTCNN and FaceNet. When SVM is used for classification, it produces results that are remarkably accurate at telling criminals apart from non-criminals. The inclusion of HOG SVM and HOG KNN methods in particular reveals their relative underperformance when compared to SVM. This project highlights the value of cutting-edge ML techniques in contemporary law enforcement applications through methodical data pre-processing, SVM training, and result interpretation. Thank you for watching this video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.